आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone. So today we are going to discuss one question on indefinite integration. So here in this question we are given to evaluate the given integral. So here we are given the integral of, in the numerator we have the 3 sin phi minus 2 whole times of the cosine of phi, and this is whole divided by, in the denominator we have the 5 minus cos square phi minus 4 times of sin phi, and this integration is with respect to phi as here given in the question. So now we are going to assume that this value of integral is equals to I. So here we have the I as equals to the integration of, here we have the 3 sin phi minus 2 whole times of, here we have the cosine of phi, and this is whole divided by, in the denominator we have the 5 minus cos square phi minus 4 sin phi, like this, and here this integration is with respect to phi. Now from this we are going to use one identity. We know that the sin square theta plus cos square theta is equals to 1. So by using that we are going to substitute the value of the minus cos square phi. So here we have the identity as the sin square theta plus cos square theta is equals to 1. So from this we can say that the sin square theta minus 1 would be the value of the minus cos square theta. So now by using this result we are going to find the value of the minus cos square phi. So here we have this integral as equals to the integration of the 3 sin phi in the numerator minus 2 whole times of the cosine of phi, and this is whole divided by, in the denominator we have the 5, and instead of minus cos square phi we are going to write the sin square phi minus 1. So here we have the plus sin square phi minus 1, and here we have the minus 4 sin phi, like this. So this can be rewritten like, here we have the 3 sin phi minus 2 whole times of the cosine of phi, and here we also have the integration with respect to phi, and in the denominator we have the 5 minus 1, that is 4. So here we have the 4 plus sin square phi, like this, and here we have the minus 4 sin phi, like this. So this is what we have got here. Now after this we are going to solve this integration by using the substitution method. So for that we are going to assume that here we have the sin phi is equals to t, and here we forgot to write the d phi here. So now we are going to substitute that the sin phi is equals to t. So if we take the differential on both the sides of this equality, then we get the differentiation of sin phi is cos phi. So here we have the cos phi d phi would be equals to the dt. So now we are going to substitute these values here in this integration. So if we do that, then we finally get the value of I as, here we have the integration of 3 sin phi. So instead of sin phi we put the t. So here we have the 3t minus 2 times of, here we have the cos phi d phi, and the cos phi d phi is equals to dt. So here we have the dt whole divided by, in the denominator we have the 4 plus sin square phi is t square minus 4t, like this. Now if we solve this ahead, then we get the 3t minus 2 times of dt whole divided by, in the denominator we can see that here we have the t square plus 2 square minus 2 into 2 into t. So it forms the identity of the t minus 2 whole square. So it can be rewritten like the t minus 2 whole square, like this, in the denominator. Now if we solve this ahead, then we get, here we have the integration. Now in the denominator we have the t minus 2 whole square. So in the numerator we are going to add and subtract with plus 6. So if we do that, then here we get the 3t, and here we have the minus 6, and since we have done the minus 6, so we are also going to do plus 6. So we have the plus 6 and we also have minus 2. So the plus 6 minus 2 would be, here we have the plus 4. So here we have the plus 4 whole divided by, in the denominator we have the t minus 2 whole square, and this integration is with respect to t. So we have got this thing. Now we are going to separate this integration with respect to this positive sign here. So if we do that, then here we get the value of this integral I as equals to, here we have the 3t minus 6. So if we take the 3 common out, then 3 is outside, and inside we are left with the t minus 2. So here we have the t minus 2 in the numerator, and in the denominator we have the t minus 2 whole square, and this integration is with respect to t. and here we have the 4 times of, here we have the dt whole divided by the t minus 2 whole square, like this. Now here we can see that this t minus 2 gets cancelled out with 1 t minus 2 in the denominator. So if we integrate this, then here we have the dt upon t minus 2. So the integration of it would be the 3 times of the logarithm of the t minus 2, like this. And here we have plus, now we are going to integrate it. So here we have the integration of the power of t minus 2 as 2, or we can say that if we bring this on the upper side, then we get the t minus 2 whole to the power minus 2. So if we integrate this, then here we get the t minus 2 whole to the power minus 2 plus 1, that is minus 1 whole divided by minus 2 plus 1, that is minus 1. So this we have got, and also we have got the constant of integration, that is plus c. So if we solve this side, then we get the value of phi as the 3 times of the logarithm of, here we have the t minus 2, like this, and here we have the minus, so this minus comes here, and here we have the 4 times of, here in the denominator we get this t minus 2, so here we have the t minus 2 plus c, like this. Now for solving this, we are going to resubstitute the value of t. So here we substituted t as equals to sin phi, so we are going to resubstitute it. So from this we get the I would be equals to, here we have the 3 times of the logarithm of, and inside the logarithm we have the sin phi minus 2, so here we have the sin phi minus 2, and here we have the minus 4 whole divided by the, instead of t we put the sin phi, so here we have the sin phi minus 2, like this. And here we also have the plus c as the constant of integration. So here in the question they have asked us to evaluate the value of the integral. So here we have got the integral as a 3 times of the logarithm of the sin phi minus 2 minus 4 whole divided by the sin phi minus 2 plus c as a constant of integration. So this is the value of our integral, and this is our solution. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।